Thank you so much for joining us this morning or evening if you're in France. We're happy to have you. Always fun to be hosting a webinar and just being able to be a resource for knowledge and welding, staking, all that good stuff. So happy to continue to do this as a free resource for you guys and to just help you solve your plastic problems. But just a quick little intro for those of you who don't know me and Kelly. My name is Catherine Urives. I am the inside sales engineer here at Extol. So basically, if you've got an inquiry and you submit something through our website or give us a call, I'm the one who's going to respond, talk to you about your application and see if we've got something that's a good fit for you. I was going to keep going about.
No, go for it. Sorry.
My background is in our applications lab, which Kelly will talk about in a second. But so I've been in every single one of these pieces of equipment, used them, broken them, put back together again. So I'd like to think I know the technologies fairly well. And then I've got the best co-host here, Kelly. She's next to me. If you haven't figured that out by now, but I'll let you introduce yourself.
Yeah, I'm Kelly Benendijk. I am the manager of our applications lab here at Extol. So within Extol, my team are the process experts. So we love that we get to work with all of you lovely customers or hopeful customers out there that are bringing us applications for us to help you decide what's the right technology, what's the best design for that technology to work with the different technologies. My group also does prototype testing. So if you're trying to make sure that the technology is the right fit or that you can meet the specs that you need, or you just need some parts even for your internal validation testing or what have you, my group is the team that does that.
Yeah. So a little bit of who we are, maybe why we kind of know what we're talking about sometimes. And then if you're new to an Extol webinar, we're trying to, do this a little different, not just bore you with words. This is for you guys. So if you have questions or anything, feel free to throw it in the chat. We'll be monitoring it. Don't wait till the end because, I don't know, maybe you'll forget what your question was by then. So if you've got a question, throw it in wherever. Maybe we'll address it in a later slide or something like that, but we'll just let you know. So this is interactive. This is your time. Ask whatever you want to ask. So I guess a little softball question for you to kind of get you, comfortable with the chat here. Just wondering maybe why you signed up for this webinar. Maybe you signed up because you've got a spin welding project going on right now. Are you just interested in what spin welding is? Wanted to learn more about plastic joining in general, so you decided to sign up for this super cool webinar. Just curious maybe what some of the reasons were for joining. Informational, yep. Let's get some more insight on what joining looks like.
Mm-hmm.
Refresher, yeah, nice.
Current project, yep.
New to plastic welding, getting to know different types of welding and its applications. You've come to the right place. We got someone typing. Refresher. Yeah, nice. So hopefully this will be a good refresher, or for your new project or current project, feel free to, ask questions, or afterwards we're happy to follow up and, maybe touch base on anything that's not covered. So for some of you, you might have seen this before, you know who Extol is, but for people who have not, just wanted to give a little bit of a kind of summary of who we are at Extol. We find that people kind of know us for whatever their first interaction with us is. So like for integrators, we're the people who make staking equipment, or maybe we're the people who make the hot plate welder, the rapid conductor, So really, Extol has so many other areas than that. So just to give a little summary or maybe a refresher, our goal as a company is to solve your complex manufacturing challenges. So we actually kind of depict this in our logo, what our goal is in working with you. So we find in the industry, there's kind of two groups of people. You've got people with their plastic welding expertise, they make plastic welding equipment. And then you've got people with custom automation expertise. Now, people with plastic welding expertise do really well with understanding like what's happening in the process to the parts, but they don't necessarily adapt their technology to fit your application. So if it doesn't fit in their sort of box or footprint, then it's just not feasible. Meanwhile, for custom automation people, machine builders, the sky's the limit. They can make anything work with enough money. However, they might not necessarily have that deep technical knowledge to make a welding process successful. So where Extol comes in is we're the best of both. We try and pair the plastic welding expertise with the custom automation expertise. So you can get a configurable plastic welding solution that is also optimized for performance. We do anything from integration equipment all the way to fully automated lines. So this even helps us work well with maybe a preferred machine builder or an integrator, because we know what it takes to integrate our own equipment. We do it in our own machines all the time. So even if you have a preferred partner that you work with, please don't shy away from utilizing us as a resource, because we do offer integration and anything in between. So the way that we kind of support you through your process is with engineering services like 3D printing, development work, like Kelly said, with her team doing feasibility studies or maybe a prototype part run. And then even we'll do some validation testing in-house. And then, of course, we've got our different technologies. We've got our IR technologies like InfraGuide, InfraStake, laser, InfraWeld, and then we've got our contact processes like ultrasonics, spin welding, which is why we're all here, hot plate welding, nanostake. So those are kind of the core technologies that we'll utilize as tools in the toolbox. And then, like I said, we'll do anything from integration packages all the way to fully automated machines. We want to configure our product to your needs. We don't want to just sell you a standard machine that maybe has not enough features that you're looking for, or maybe more than enough features, they're just extra and adding extra cost for no reason. So we really want to configure our equipment to your needs. So that might look like a standalone machine, that might look like a fully automated line. We're happy to work through that process with you. Like I said, we want to partner with you through the entire development of your project. We'll help with manufacturing concept ideas. You need to hit a volume of X. You've got this many operators. What does the equipment need to look like? We'll give part design advice. We'll do feasibility studies at no cost to help you build your part design to be best suited for plastic joining. We'll do 3D printed samples. We can weld them. We'll do feasibility testing and early trials. So prototype welding, validation, all that kind of falls into the next level of the cycle. And then, of course, we'll do the equipment, integration packages, standalone machines, full assembly lines. I think something that's a little bit more unique to Extol is we'll also help with service, installation of equipment. We've got a full spare parts team. We'll help with troubleshooting should anything arise during production. And then lastly, we offer post-production support. So if you want to retrofit the machine for a different program, get a different tool in there, utilize that capital, we can help you with that. We can get you new tooling to run that program, or we'll refurbish old equipment. So our job is really to be kind of that one-stop shop for you, a resource throughout your entire project, where when something hits your floor, you're quoting it, you're designing it, like we want to walk with you through that process, because honestly, in the end, it makes our life easier because we've got all this history and the part is built for your specific joining, but also it helps you because we've got all the background knowing what the equipment needs to hit in order to produce the parts that you're desiring. So that's kind of Extol in a nutshell. If you have any questions about what our capabilities are, feel free to ask. But I'll kick it over to Kelly now to talk a little bit more about spin welding. I know that's why you're all here. So
yeah, the meat of the presentation here. Okay. What is spin welding? So it's a pretty basic process. You're basically just spinning two parts together. So it's a frictional joining process. So as you're spinning, you're creating friction, which creates heat, which then melts the plastic, of course, and you're putting it under pressure on the z-axis. So once that you have that molten material, it's going to bond the plastic together. So it produces very strong welds, and you can get a nice hermetic seal. So hermetic just meaning you're not going to have water or air leaks, so it's going to be tight to that. So it can be a very robust process as long as it's designed correctly.
There's the kicker.
Yeah,
as long as it's designed properly.
And that is why my team's here to help you and make sure that it's designed correctly.
Yep.
All right. All right, so you can see this very simple process right here. So what we're doing with spin welding is we are holding that bottom part stationary, and then we're just spinning the top part. So as you can probably guess, a critical design feature that you need with spin welding is the weld joints itself. Both the upper and the lower have to be circular to be able to spin these parts together. You can't spin a square. You can sometimes spin an oval, but that's a conversation for another day. But for the most part, at its basic level, the two joints need to be circular. You're spinning one against the other, creating that friction that we just talked about, and melting the plastic. And when you have it under force, the materials will bond together. So very basic process. In concept.
Mm-hmm. So here's a quick little video of the process. And when I say quick, I mean, it's a quick process. Hopefully the video is playing on your end. It's a little laggy on mine, but maybe we'll run it through a couple times just in case it's delaying. But anyways, parts are loaded. One part spins on the other. The machine abruptly stops. That is a key characteristic so that you don't shear that newly formed joint that you just created. Would you mind hitting play again, just in case?
Yep.
Thank you.
Go for it.
Yeah, so simple. Parts are ready to handle immediately after the process is complete because no, heated tool is utilized to come in contact with the part. But
yeah, and while we're here, just to point out maybe the obvious, but your parts themselves don't have to be fully circular. As you can see in this video, that bottom part is clearly not circular. The weld joint is, but the part isn't. And then you've got that port that's not, it's kind of that L-shaped port, but the joint itself is circular. So just wanted to point that out here. All right, let's get into the real meat and potatoes of this guy. All right, so our machine that we are currently running with our platform is called the Vortex Eminence. And so this is the main weld screen that you will see. So with the main parameters, there are clearly other screens that you'll see down at the bottom there. But this is going to be the bulk of the parameters that we have to play with. So I was just going to talk through some of this, and this will help explain what some of your options are and some of the key features that you can do while spin welding and how you control the spin welding. So first, I want to bring your attention to these two notes at the top here. So in green, you see we have Z-axis, and then in the yellow or orange, we have the spin axis. So as you can see, as you're looking at this screen here, some of these down here are going to be in green, some of them are in yellow. So these are just denoting which of these controls are related to the Z-axis, so that's the up and down, and then which of these are related to the spindle axis and movement. Okay, so next we have the weld mode. So there are 5 different weld modes that you can use to tell the machine how do you want to control your weld. So the first one is going to be collapse. And so this one is basically telling the machine from the time the two parts see force. So they basically start touching those from the time those two parts start touching to whatever your collapse distance that you set is, that's your total collapse. So if you have it set by collapse, you're gonna this screen would actually change. So instead of by rotation, it would be by collapse. So you would just set a distance there. So this is a really good mode to use if you have a certain height of your assembly that you're trying to hit. If that's the most critical feature to your final assembly, is that final height, collapse is a really good mode to use. All right. The next one is going to be position, so welding by position. So this is very similar to collapse mode. The only difference is, so instead of measuring from like the part to the bottom, it's just going to measure a position in space. So the machine has has a 0 point where its head up position is, and then it's going to go, it's got a scale along it. So you can just tell the machine along that scale, where do you want that to stop? So again, that can be one that you can use to control height. It's just kind of another option. I tend to prefer collapse a little bit better, but there's definitely instances where position may be helpful. So it's just a good option. All right, the third weld mode is going to be time. And I'll be honest, this is rarely used. It's probably the most crude method. So this is just, you're just welding it, telling it to keep rotating for a certain amount of time. So it's possible you have an application that uses this. I very rarely use it, but again, options. The fourth one here is going to be welding by rotation. This is actually the one I think I use the most. I find it to be the most consistent as far as weld quality goes. So what you're doing here is you're telling the machine how many total rotations do you want it to go before it stops spinning. So that's pretty basic. But again, so that's going to start, just like collapse, it's going to start when the two parts touch each other, when you start seeing that force. So I really like rotations, but that is not quite as consistent as collapse when it comes to the final part height. So I would say that if you're most concerned with the strength of your weld, that's probably what I would go with. And then this last one here is welding by energy. So with this one, this is actually a newer one for us. But what the machine's going to do with this is it's going to multiply the speed of the spindle times the torque, which is going to give you a power curve, and then the machine's taking the area under the curve to get your total energy. So that's the total energy that you're putting into that weld. So that can be good with certain tricky applications where you're trying to make sure you're getting the same amount of energy into it. So that's another good option. All right, so some of the other features on this left-hand side over here. So start positions. So our equipment gives you the option of starting spinning at a programmed position. So again, you have that scale, along the whole travel distance. So you can start at a specific position, or you can just tell the machine to start when it starts seeing force. So that's that detect. And I would say that detect is what we're using most of the time. But again, there are instances where programmed might be helpful. Okay, other options. So when does the machine start spinning itself? So there are two modes here. There's going to be static mode and dynamic mode. Static mode is what I use the most. So that is telling the machine that it should not start spinning until those two parts come together. Dynamic, it would start spinning before the two parts come together. Again, I like static mode. Dynamic, though, can be really helpful, especially if you have parts that need a lot of torque to get going. Say they're either bigger parts or they've got a lot of filler, which is going to create a lot of friction. They have a lot of friction, so they're harder to get going. So I've seen dynamic mode be helpful because it lowers that torque needed to really get it going. Mm-hmm. And then you have the option to spin either clockwise or counterclockwise. I have never needed to go backwards, but maybe you want to. I don't know.
Maybe you're an Australian,
Maybe.
just really want to see things go the opposite direction.
Maybe. All right. And then let's come over to this middle section here. Again, this is going to change a little bit depending on which of these 5 weld modes you have selected. But we'll talk about that as we get there. All right, so your start max position is going to be, you're telling the machine so if you've got it on detect mode, say, the machine's going to be looking for a certain point in which it expects to see force because it's expecting to see those parts come together. What you're telling the machine with this start max position is if it exceeds that position that you set, then something's wrong. So maybe you don't have a part in, maybe you have the wrong tools in, I don't know. But if it doesn't start seeing force by that position, it's going to throw an error. So, and of course you can teach that position if you're jogging around in manual. Okay, so max speed here is, so this is in green, so it's going to be your z-axis speed. So you're telling the machine how fast what is the max speed that you want it to travel in the z direction. Next is going to be your collapse max distance. Sorry. So this is the max collapse. Well, okay, so this one right now, this is set to be controlled by rotations. So this is kind of the backup, like if it exceeds this amount of collapse, then you want the machine to stop. So this kind of helps with, is that in between of, you want the consistency of welding by rotations, but you also want to be able to control your height somewhat. So this will help you have that max height that you want the spindle to go. So, and what happens there? So if you meet that max collapse distance and it still has rotations to go, it'll just stay at that same height and continue to rotate. So it'll still put heat into your part, but it just won't be traveling downwards as it does that. All right, variable force profile. Let's get up here. Variable force profile. So you have the option both with force and with distance to program 5 different points along that profile. So meaning you can change the force as you weld, or like if it's stopping at different heights along the weld. So why might that be helpful? Especially the force one. So sometimes you don't want as much downward force as you're getting started because that creates more torque that you have to overcome to get the weld going. So you might have a lower force at the beginning, and then as that plastic starts to melt, you can add more force to really push those materials together to get a good bond. So that's a great option that is new for this Vortex Eminence. And then of course downward force here. So how much force do you want down? All right. The right side here, so number of rotations. So this is going to change based on which of these weld modes you have set. The speed. So the speed of your weld, you should think of this kind of as a temperature. So if you're rubbing your hands together, if I rub them really slow, it stays pretty cold. If I rub them, the faster I rub them, the hotter it's going to get, right? So same thing with spin welding. The faster you go, the more heat that you're getting into your parts. And each different plastic material has a different speed or temperature that it wants to be at. So my team has lots of experience with different materials, so we can help you to set that speed based on whatever material you have. Acceleration and deceleration is how fast or slow we're speeding up or starting the spindle and slowing down the spindle. Orientation. So if you need to stop at a certain point, so if you want your parts to be clocked a certain way at the final weld, you can set that final angle up to 1/10 of a degree. So that's a great option. You know, a lot of customers need to stop it with a certain orientation. All right.
I feel like the biggest thing, if you haven't picked it up already, is that each process is highly configurable to your specific application. There's a lot of levers here that you can pull to dial in your specific process for your part design, for your acceptance criteria, for your needs. So it's kind of our theme here, is that we want to make our product be able to make your application successful, not if you can't fit in our box, carry on. So we're kind of running out of time here. We just have so much content that we wanted to shove in here for spin welding. So if you have to jump off, we will not be offended. There will be a recording that's sent out after. But if you can hang around for a couple extra minutes, we're just going to try and kind of blitz through these last couple slides here, and then we'll reach out and ask if you've got any questions after the webinar. But here is the home screen for the Vortex Eminence. As you can see, it's got in-process monitoring, and it shows as a graph, so you can maybe see if your part's misloaded, or if you get an error flag, you can see with the graph what happened during the process. So a cool new feature of the Eminence for sure. And then benefits of spin welding, Kelly kind of touched on them. Hermetic seal, you get a robust weld. Immediate assembly handling. I feel like one that's really cool about spin welding is the quick tooling changeover, because nothing's heated up, and then that you can contain other parts inside your assembly without having to worry about maybe it touching a heated tool, or getting too close to something hot. So like mug liners, we've done stuff that fluid gets added to the part before spin welding. Maybe an internal something is moving around, that hot plate welding might not be an option. So I think that's something else that's really unique about this spin welder. And then requirements. The materials need to be compatible, and what that means is that, at a chemical level, when these materials are heated up and smashed together, it will create new bonds. If you have incompatible materials, that material will kind of sort of grab onto each other, but really it's weak. You could probably rip it apart with your hands. And in fact, I've seen people do it many a times. It's kind of a fun little test that we'll do sometimes. Circular weld joint, like I said, sometimes you can do an oval, but we won't get into that. And then you need drive features to transfer the torque to actually get the parts to spin. Sometimes you can have just purely cylindrical parts. However, you do run the risk of tooling maybe marring the part. So just something to keep in the back of your mind.
Yeah, so when we say drive features, we mean gussets, or just innate features in the part, or maybe holes, like something that we can mechanically grab onto to turn that part.
Yeah.
All right.
No.
Yeah, this is mine. All right. Materials. So lots of different materials can work with spin welding. So to begin with, it has to be a thermoplastic. So we have to be able to remelt the plastic. So it cannot be a thermal set. Within that, the materials do have to be compatible. If they are two different materials, sometimes they will work and sometimes they won't. So in general, this is not the hard and fast rule, but in general, amorphous materials like amorphous, semicrystalline like semicrystalline, there is some crossover, but that's just a general rule. Composite materials work. Resins with different fillers are actually really great with spin welding. Some of the other technologies, they're not, but with spin welding, glass and talc just adds friction, and we like friction with spin welding. So, the glass-filled nylon's great, glass-filled PBT, great. So on the challenging side, the opposite of that is materials that don't have a high coefficient of friction. So Teflon, acetal, sometimes polyethylene, those more slippery materials can be really difficult. So, So 3 different joint designs. These are the most common that we see. There are others, but these are the most common. The one on the left is going to be a basic butt joint. So just a flat to a flat. This is very easy to design for. However, I would say that this is the least strong of the joints and the most susceptible to leaking. So it can be welded, but it's not going to be super robust. Okay. Let's flip to the other side on All right. On the right-hand side, that is going to be a tongue and groove joint. So this takes the most real estate, but it is by far the strongest joint. So this is what we recommend the most, this guy over here. And the reason that it's the strongest and has the least potential for leaking is that essentially you have two weld surfaces. So you have a weld surface here and you have a weld surface here. So you're getting double the surface area for that weld strength. And if water or air needs to pass through it, it has to pass through both of those surfaces. So this tongue and groove is what I would recommend if you have the side-to-side space for it. This middle guy is another good option. It's not quite as strong as the tongue and groove, but we see this a lot, and it's still a very good joint. This is a shear joint, so you can ignore this guy over here, but this is basically you're just shearing down the side from one to the other, and that can provide a very strong weld. Of course, you're only getting one surface area of weld as opposed to the two here, but still very robust. And you'll note that these two over here are also nice. These align to themselves, so that can help with that circularity too. Right.
Yeah, and also just one other thing about the joint design is the flange shear and the tongue and groove. They both also help accommodate for more warp in your part. It's a little bit more forgiving versus that butt joint. If you're not getting that immediate contact, there's a lot higher chance that your assembly is going to fail, especially a hermetic test. But I'd say the biggest industries that we see spin welding applications for are like automotive. That's probably the biggest one, under hood, because a lot of nylon, so you can't necessarily hot plate weld those applications. We'll see some medical. Consumer products is also a big one for spin welding. It's fast, it's cheap. You can have a little bit more of unique shapes in consumer products, I feel like, than maybe some other industries. And then, of course, infrastructure, you've got a lot of piping and tubing and stuff. So that's another big industry for spin welding. But overall, I'd say the biggest one is likely automotive.
Yeah, but we've seen all
kinds of
different applications.
Yeah. So that's our content for you. We really busted through those last few minutes, but obviously we've got resources for you like the lab, our website. If you've got questions, we'll follow up and reach out after the webinar. But if you enjoyed it, first of all, well, thank you for being here. Yeah. If you enjoyed it, feel free to leave an emoji or something on how you feel about the webinar. And in the chat, maybe if you want to have Extol train your team on spin welding or another technology, we'd be happy to come and do a lunch and learn or a webinar specifically for you guys tailored to your sorts of applications. And then if you've got any topics that you want to see for our next webinar, our last one was laser welding. Maybe you saw that and were curious about spin welding. Or maybe you really want to understand more about hot plate welding. Maybe we didn't go into enough of assembly criteria and what maybe that means for each application. If you've got something in particular you'd like to see, feel free to drop it in the chat, and we'd love to arrange that or take it into consideration for our next webinar. But thanks so much for joining as the little hype cat is going in the corner. We're happy you're here. Hope you have a wonderful rest of your day. And yeah, thanks so much. See you next time.